The Ticonderoga-class cruisers represents a paradox that perfectly encapsulates the challenges facing modern defense procurement and strategic planning. They are simultaneously too outdated to be efficient, but too capable to be easily replaced. Born in the Cold War to fight the Soviet Navy, they now find themselves at the center of debate about how to respond to China's rise as a naval power. Imagine a class of warships so powerful they form the backbone of the US Navy's air defenses, yet so old and expensive to maintain that the Navy wants to get rid of them. That's the dilemma of the Ticonderoga-class cruisers. Today, we're examining the future of America's guided missile cruisers. We'll explore their storied history from Cold War origins to present-day controversies. Examine why they remain strategically irreplaceable in an era of great power competition. Understand the mounting maintenance costs that are bleeding Navy budgets dry. And analyze the high-stakes political battle between Pentagon leadership and Congress over their retirement. Most importantly, we'll look at what might replace them, and whether the Navy can afford to wait. The story of the Ticonderoga class begins in the late 1970s, during the height of the Cold War arms race. The Soviet Navy was expanding rapidly, fielding increasingly sophisticated surface combatants and submarines that threatened American carrier strike groups. The US Navy needed a response, something that could provide comprehensive area air defense while serving as a command platform for complex multi-domain engagement. The answer was the Ticonderoga class, entering service in 1983 as the first warships to carry the revolutionary Aegis combat system. These weren't just evolutionary improvements over existing designs. They represented a fundamental leap in naval warfare capability. Built on a conventional ship design based on the Spruance-class destroyer hull form, these ships displace roughly 9,600 tons at full load displacement. That makes them significantly larger than contemporary destroyers, but smaller than the heavy cruisers of old. Their flared bow design with sharp rake gives them excellent ocean-going abilities in rough seas, a critical factor for sustained operations in the North Atlantic and Pacific. However, their design reflects the pre-stealth era of naval architecture. Unlike modern destroyers with angular, radar-deflecting surfaces, the Ticonderogas have conventional box superstructures that present larger radar signatures. This wasn't considered a major limitation in the 1980s, when the focus was on raw capability and firepower rather than on signature reduction. What made them truly groundbreaking was their construction philosophy. The Navy chose steel hulls paired with aluminum superstructures, a weight-saving measure that allowed more space for weapons and sensors, while maintaining structural integrity. This decision had consequences that still affect these ships today. While aluminum reduced topside weight, it also reduced fire survivability compared to all steel construction. And the dissimilar metal joints between steel and aluminum have proven problematic over decades of service. But the real innovation wasn't in the hull, it was in the systems. The Aegis combat system represented the first true integration of sensors, weapons, and command systems in naval history. The powerful at the time, Spy-1 phased array radar could track hundreds of targets simultaneously while guiding multiple interceptor missiles. The earliest Ticonderoga-class cruisers, specifically CG-47 through CG-51, were outfitted with the Mark 26 single-arm missile launcher. a Cold War era system that now seems old-fashioned compared to modern vertical launchers. The Mark 26 featured a rotating arm that physically lifted missiles from a below-deck magazine and positioned them onto a launcher rail before firing. This design offered a magazine capacity of up to 88 missiles, typically a mix of standard missiles, SM-1 or the SM-2, and the ASROC anti-submarine rocket. While mechanically elegant, the system had clear limitations. It could only load one missile at a time, required physical movement of heavy components, and had a maximum rate of fire of approximately one missile every 9 to 12 seconds, depending on the readiness of the magazine and the type of missile in question. In an era where saturation attacks and rapid response are the norm, this mechanical complexity and slow reload speed quickly became obsolete. These early ships were retired ahead of their newer VLS-equipped sisters for this very reason. From CG-52 USS Bunker Hill onward, these ships carried the revolutionary Mark 41 Vertical Launch System, or VLS, replacing older single-arm launchers with a flexible, high-capacity magazine system. This modular launcher revolutionized naval warfare by allowing missiles to be launched vertically from canisters embedded directly into the deck. Each cruiser carries 122 VLS cells, 61 forward and 61 aft, giving the ship one of the highest missile capacities of any surface combatants in the world. The system can accommodate a wide range of munitions, including SM-2 and the SM-6 surface-to-air missiles, Tomahawk land attack missiles, ASROC anti-submarine rockets, and even the emerging Standard Missile 3 for ballistic missile defense. Each cell operates independently, and the hot launch mechanism expels missile exhaust into shared gas ducts located between cell banks. The Mark 41 system allows for near-simultaneous engagements, with a practical rate of fire exceeding one missile per second in combat conditions. Unlike older systems, there is no need for mechanical reloading between shots. Every cell is preloaded and electronically queued. This rapid response capability is central to why the Navy has resisted retiring the VLS-equipped cruisers too quickly. With 122 VLS missile cells, the Ticonderoga class pack more missiles than any destroyer in the fleet. To put that in perspective, that's 27% more missiles than the newest Flight 3 Arleigh Burke destroyers. That's a level of sustained firepower that few platforms in the world can really match. But sheer numbers don't tell the full story. It's the flexibility of that missile loadout that makes these ships so valuable. A single Ticonderoga can simultaneously provide area air defense for an entire carrier strike group, conduct precision strikes against land targets hundreds of miles away, and maintain anti-submarine warfare capabilities. The reason why these cruisers were indispensable to American naval power lies both in their overwhelming firepower but also their command facilities. They weren't just built to fight, they were designed to orchestrate naval battles. From day one, their operational role centered on serving as area air defense commanders and flagships in carrier strike groups, a mission that remains as critical today as it was 40 years ago. Ticonderogas are uniquely suited to serve as air defense commanders, a specialized role that requires not just powerful sensors, but dedicated command spaces, the command and control systems, and the electrical power to run it all. This isn't just about having good radar. It's about having the physical space and the computational power to process information from dozens of platforms simultaneously and coordinate defensive responses across an entire task force. Currently, only the Ticos and the aircraft carriers are certified for this critical mission, and carriers are far too valuable to risk in forward areas just to provide air defense coordination. When you see news reports of American naval forces operating in contested areas like the South China Sea or the Eastern Mediterranean, it's often a Ticonderoga-class cruiser serving as the command and control hub that makes complex multi-ship operations possible. The Spy-1A and Spy-1B radar systems provide three-dimensional tracking of hundreds of air contacts simultaneously, with a detection range that extends well beyond the horizon. This creates what military planners call Blue Force situational awareness, the ability to see the entire battle space and coordinate defensive responses before threats can reach critical assets. These ships essentially function as floating command centers, processing information from satellites, aircraft, submarines, and other surface ships to create a comprehensive operational picture. The command spaces on these ships are equally important. Unlike destroyers, which have limited space for additional command staff, Ticonderoga-class cruisers have dedicated flag officer accommodations, expanded communication suites, and the physical space to embark additional command personnel. So, if they are so capable, why does the Navy want them gone? The answer is brutally simple. They are maintenance nightmares that are bleeding the service dry, consuming resources that could be used to build and maintain more modern platforms. Most of the class has exceeded 30 years of service, and several ships are approaching 40 years old. They were originally designed for 30-year operational lives, but repeated life extension refits have pushed many well beyond the intended service periods. This isn't just about age, it's about the cumulative effect of decades of operations. Steel fatigue and hull integrity issues have become endemic across the class. Long-term exposure to stress cycles from heavy seas, combined with saltwater corrosion, has weakened key structures throughout these ships. The problems are particularly severe below the waterline and in the joints between steel hulls and aluminium superstructures. These dissimilar metal connections were problematic from the beginning, but nearly 40 years of thermal cycling and corrosion have made them increasingly expensive to maintain. The aluminium superstructures that saved weight in the 1980s have become liability in the 2020s. Aluminium corrodes differently than steel, creating galvanic corrosion issues wherever the two metals meet. Repairing these joints requires specialized welding techniques and expensive materials. In some cases, entire sections of the superstructure have to be replaced, work that can cost tens of millions of dollars per ship. But the real killer is systems obsolescence. These ships carry electronics and combat systems that were cutting edge in 1983, but are now museum pieces. Legacy systems require complete overhauls, and in many cases, replacement parts must be custom fabricated because they are no longer in widespread production. Some companies that manufactured key components may no longer exist, or have moved on to completely different product lines. Combat systems modernization presents even greater challenges. Newer versions of the Aegis combat system, like Baseline 9, have to be retrofitted into older electronic suites that were never designed to accommodate them. This creates integration challenges that require extensive rewiring, new cooling systems, and power distribution. The work is so complex that it often takes longer and costs more than originally estimated. The propulsion systems on these ships are equally problematic. The LM-2500 gas turbines that power the Ticonderogas were reliable when new, but 40 years of operations have taken their toll. Turbine blade replacements, bearing overhauls, and gearbox maintenance require specialized equipment and highly trained technicians. The Navy has had to rebuild entire propulsion plants on several ships, work that can take months and cost tens of millions of dollars per vessel. The manpower burden is equally crushing. Older ships require more manual maintenance than modern platforms. Systems that would be automated on newer ships require constant human intervention. Crew fatigue becomes a serious issue when sailors have to perform maintenance tasks that should be handled by automatic systems. This makes these ships more resource-intensive than newer destroyers, requiring larger crews and more frequent port visits for maintenance. The average annual maintenance cost per cruiser exceeds $50 to $75 million, and that's just for routine upkeep. Major availability periods where ships undergo extensive overhauls can cost between $200 and $400 million per vessel. Dry dock schedules have become increasingly uncertain. What should be 18-month overhauls routinely stretch to 2 or 3 years as shipyard workers encounter unexpected problems. This reduces the operational availability of the entire class, meaning fewer ships are available for deployment at any given time. The Navy has reached a point where some cruisers spend more time in maintenance than they do in deployment. Ships that should be deploying with carrier strike groups are instead sitting in shipyards, consuming resources without contributing to naval operations. This creates a vicious cycle where the remaining operational ships are overworked, leading to more maintenance problems and higher cost. Every dollar spent keeping these aging platforms operational is a dollar that can't be spent on newer, more capable systems. The resources consumed by Ticonderoga-class maintenance could be used to accelerate production of Flight 3 Arleigh Burke destroyers or development of the DDGX. This maintenance crisis has created an unprecedented political battle between the Navy and Congress over the ship's future, a conflict that reveals deeper tensions about defense spending priorities, strategic planning, and the balance between current capabilities and future requirements. The Navy's decommissioning plan is straightforward and, from their perspective, logical. Phase out the 20 or so remaining cruisers by the early 2030s, including decommissioned ones in the reserve fleet. The Navy argues they are too expensive, maintenance-heavy, and increasingly unreliable to justify. Navy leadership views this as essential resource management. The service wants to accelerate production of more modern platforms while divesting legacy systems that no longer provide cost-effective capabilities. The Navy's planned force structure shift focuses heavily on the Flight 3 Arleigh Burke destroyers and the future DDGX program to assume command roles currently filled by the Ticonderogas. From the service's perspective, this represents necessary evolution toward more sustainable platforms that can better handle 21st century threats. But Congress sees the situation very differently, and the political battle has become increasingly heated. Bipartisan concerns centers on the belief that retiring Ticos prematurely will create a dangerous capability gap in air defense command at exactly the wrong time. The political dynamics are complex. Members of Congress from districts with shipbuilding industries worry about the economic impact of reduced maintenance contracts. Elders focus purely on capability concerns, arguing that losing the command and control platforms will weaken American naval power during a period of intensifying naval competition with China. Some individual ships have become political footballs. USS Vicksburg, for example, was scheduled for decommissioning, but was ordered back into service by congressional mandates, despite Navy opposition. The ship underwent a costly modernization program that the Navy argued was unnecessary, consuming resources that could have been better used elsewhere. The House Armed Services Committee has been particularly aggressive in blocking cruiser retirements. Committee members have argued that the Navy's assessments are flawed and that eliminating command platforms before replacements are available creates unacceptable risk. They've inserted language into defense authorization bills, specifically preventing the retirement of cruisers until certain conditions are met. This political tension has created an impossible situation for Navy planners. They are forced to maintain ships they consider obsolete while simultaneously developing and procuring replacements. The result is a resource strain that cripples the entire surface fleet. Ships are being modernized under protest, with Navy leadership publicly stating they would prefer to spend the money elsewhere. The disagreement reflects fundamentally different approaches to risk management. The Navy sees continued operations of these ships as higher risk than temporary capability gaps, arguing that mechanical failures and maintenance-induced unavailability makes them unreliable. Congress sees capability gaps as higher risk than the mechanical problems, arguing that having flawed platforms is better than having no platforms at all. Ships that were supposed to be decommissioned are instead consuming dry dock space and skilled workers that could be used for other projects. This creates cascading effects throughout the naval shipbuilding industrial base. The political battle has become so contentious that some Navy officials privately described it as the worst civil-military relations crisis in decades. Senior officers find themselves in the uncomfortable position of publicly defending programs they oppose while privately lobbying for policy changes. This tension undermines morale and long-term planning for the entire fleet. So what's the replacements plan, and why isn't it working? The answer reveals the enormous challenges facing naval modernization in an era of rapid technological change and constrained budget. The primary replacement for Ticonderoga-class cruisers is supposed to be the Flight III Arleigh Burke-class destroyers. These ships represent a significant technological advancement over earlier Burke variants, incorporating the powerful SPY-6 radar system and the latest Aegis Baseline 10 combat system. The SPY-6 radar is roughly 30 times more sensitive than the SPY-1 systems on the Ticonderogas, providing dramatically improved detection and tracking capabilities against modern threats. Flight III Burkes also feature improved electrical power generation. Their electronic warfare systems are more sophisticated, their communication systems more capable, and their overall survivability is superior to the aging cruisers. But here's the critical limitation. they still lack the internal volume and command space that makes the Ticonderogas so valuable as flagship platforms. The Burke-class hull, while proven and reliable, simply doesn't have the physical space necessary to accommodate large command staff, extensive equipment, and the additional command personnel. More concerning is the missile capacity issue. Flight 3 Burkes are limited to 96 VLS cells compared to 122 on a Ticonderoga. That's a 21% reduction in missile capacity per platform, a significant decrease when you consider that modern threats require at least 2 interceptors per target. When you retire a cruiser and replace it with a Burke, you're not just losing command capability, you're losing firepower. The Navy's long-term solution is the DDGX program, which promises to address many of these limitations. DDGX is envisioned as a much larger platform with expanded power generation capabilities, space for directed energy weapons, larger sensor arrays, and the internal volume necessary for command operations. But DDGX faces significant challenges. The program is still in early development, with the first hull unlikely to be operational until the early 2030s, far too late to prevent a capability gap as the Ticonderogas are retired. Even optimistic projections show a 5 to 7 year period when the Navy will have fewer command platforms than current recommendations. The mismatch in the timeline creates a dangerous operational gap. If all Ticonderogas are retired by the early 2030s, as the Navy plans, there will be a period when the surface fleet lacks adequate command platforms. This forces uncomfortable choices. Either overload Burke-class destroyers with missions they weren't designed for, or stretch carrier-based command capabilities thinner than military planners consider prudent. International partnerships offer another potential solution. The Navy could work with allies to develop shared command platforms, or distribute command responsibilities across multiple nations' ships. However, this approach raises questions about operational security, command authority, and the reliability of coalition partnerships during crises. What's truly at stake here goes far beyond budget numbers, shipyard schedules, or even individual platforms. This debate touches the core of American naval strategy and the nation's ability to project power in an increasingly contested global environment. The strategic timing couldn't be more challenging. The United States faces growing pressure in the Pacific from China's expanding Navy, which now fields over 370 battle force ships compared to roughly 290 for the US Navy. Chinese naval expansion isn't just about numbers, it's about quality and capability. The People's Liberation Army Navy now operates highly capable destroyers and frigates, and a growing fleet of aircraft carriers that can challenge American naval dominance in the Western Pacific. Losing the Ticonderogas removes a key counterweight in this naval arms race precisely when it's needed most. The capability loss extends beyond raw firepower to the fundamental idea that a modern navy is a system of systems, and this isn't just a buzzword. The Navy's distributed maritime operations strategy depends on having multiple command nodes that can coordinate widely dispersed forces while maintaining communications and sensor integration. Ticonderoga-class cruisers serve as critical nodes in this network. providing the command infrastructure necessary to execute complex operations across vast oceanic distances. Regional allies and partners are also watching this debate closely. Countries like Japan, Australia, and South Korea have invested heavily in their own Aegis-equipped ships, expecting to operate in integrated task forces with American platforms. The loss of American command platforms could complicate coalition operations and reduce the effectiveness of Allied naval forces. The budget constraints versus military readiness dilemma reflects broader challenges facing defense modernization. The Navy finds itself walking a dangerous tightrope between saving money for future capabilities and maintaining current warfighting capacity. Every dollar spent on Ticonderoga maintenance is a dollar not available to build better warships in the future. The question facing naval leadership isn't just about these 20 or so ships. It's about whether America can maintain naval superiority during the most challenging strategic transition in decades. Should the Navy push these cruisers into retirement to free up resources for future platforms? Or should it invest in keeping them battle-ready until some undefined future date?